Just see in this part, I have assumed this green particular shape is interface of two separating medium. This medium will be any liquid and this will be air, or this will be liquid or this will be air. So this green part will act as interface between two separating medium. And since surface tension acts tangentially to the interface of two separating medium, so I have just drawn surface tension along this direction and along this direction. So this surface tension may get inclined at this theta related to horizontal, so it will have t cos theta component and t sin theta component. Similarly for this part, t cos theta component and t sin theta component. Now at this, we have pressure from outside to this surface, which is called P naught, and a pressure from inside, which is Pi. So at equilibrium, you will say this acting towards downward, the component of surface tension must be acting some pressure towards downward direction. And these two pressure is balanced by a pressure from inside Pi. So we can write Pi equals to P naught plus pressure due to 2 times of T sine theta or due to surface tension. So from this we have concluded Pi is equals to this plus this. So if you compare this part and this part only, so this will be stronger as compared to P naught. And Pi is towards concave side and P naught is towards convex side. So from this we have concluded concave side is always greater than convex side. Hamza, is it clear?
Yes, sir.
Any more doubt to any one of you?
No, sir.
Okay. So in last class, we have calculated excess pressure or pressure difference between bubble and drop. Now, let me give you a question related to this part. You will be asked, suppose there is a tube from which a balloon at this point another one at this point is attached. This is larger balloon and this is smaller balloon. And suppose there is knob at its midpoint, which is initially closed. How will size of these two balloon will affected on opening of knob? How will size of balloon be affected on opening knob? Try to answer according to the above concept. Khalid, any guess what will happen? Will the size of larger will decrease and smaller will increase to attain
Yes.
same size
Yes, sir.
after some time?
Yes, sir.
Okay, good answer. Hiba, would you like to change your answer? or you will go with this? Hamza?
Sir, it will change instantly.
Okay. How will the size of these two be affected? The smaller will start increasing and larger will start decreasing.
Yes, sir, until they will be equal.
Okay. Just say this above part in which I have defined you. Pressure difference is inversely proportional to radius. So smaller drop, smaller bubble will have large pressure difference as compared to larger one. Is it clear?
Yes, sir.
Okay. So which of these two balloon will have large pressure difference, smaller one or larger one?
The smaller one.
Good. And as we know, matter will move from higher pressure to lower pressure. And since in this part, we have the smaller balloon having higher pressure as compared to larger balloon, so air will flow from smaller to larger. Is it clear?
Yes, sir.
So will the size of a smaller will increase or decrease?
Sir, decrease.
Good. So it will start decreasing like this. Consequently, size of larger will start increasing like this. Khalid, is it clear?
Yes, sir.
So a smaller balloon will tend to acquire much smaller till it get attached to this neck, and larger will start increasing to acquire its maximum shape. Salman, is it clear?
Yes, sir.
Okay. So in this part, you will say, since smaller will have large pressure difference, so air will tend to flow from smaller to larger. Hence, size of smaller decreases and larger increases. Just write it down. Okay, you all have written?
Yes, sir. Done.
Now, the next part of this term is its application, which is capillarity. So let me define you what do you mean by capillarity. If you insert any tube in a particular liquid, on the basis of their surface tension, level of liquid may increase or decrease depending upon their interaction with that tube. Suppose I've just taken 3 different tube, test tube or capillary tube, in which in first part, if you dip in this particular capillary tube in water, shape of capillary or meniscus of liquid will be like this. In second part, if you insert glass tube in rose water, shape of meniscus will be like this. And third part, if you insert glass tube in mercury, shape of meniscus will be like this. So in first part, this sideways liquid will tend to increase its length in upward direction, or you will say there will be upliftment of liquid in this particular tube. In second part, there will be no change in its level, it will remain same. In third part, due to its side interaction, it will tend to decrease its level of liquid, so level of liquid may get fall. So due to its interaction, liquid and its side wall of capillary tube, the rise or fall in level of liquid is termed as capillarity. So capillarity is nothing but phenomena of rise or fall in level of liquid in these capillary tube when it is dipped in any particular liquid depending upon their interaction or surface tension. So capillarity is the rise or fall in level of liquid in thin tube due to molecular interaction. It's called capillarity. Is it clear, Hamza?
Sir, will it be because of liquid or the tube?
Due to interaction between them.
Okay, sir.
In first part, you will say, if you draw angle of contact, so one of the tangent will be along this direction between air and liquid, and the other will be along this direction between solid and air. So the angle in between them will be theta, which is behaving as acute. In second part, one interface is at this point, and the next interface is at this point. So the angle in between them is 90 degree. In third part, one of the interfaces is at this, and the other is at this. So the angle in between them is obtuse. So if theta is acute, means angle of contact it is acute, adhesive force will be stronger as compared to cohesive force. So it will tend to increase in level of liquid. So level of liquid will rise. In second part, if theta is 90 degree, so adhesive force will equals to cohesive force. So level will remain same. In third part, if theta is obtuse, so it will have stronger cohesive force as compared to adhesive force. So it will tend to decrease in level of liquid. This first is case of water in glass tube. Second one is case of rose water in glass tube. And third one is case of mercury in glass tube. Is it clear?
Yes, sir.
Just write it down. Hamza, done?
Yes, sir. Done.
Now, let me calculate how much level of liquid will rise or fall in these capillary tube when it is dipped in any bath. Suppose you have liquid in which a capillary tube is inserted like this. So due to its interaction, level of liquid, I'm just supposing it will increase. So it will tend to act like this. Like this. So in this case, you will say this amount of liquid has risen up. So at equilibrium, you will say there will be force acting on this raised liquid towards downward direction due to gravity, which is balanced by its interaction on its boundary due to surface tension, or you say adhesive force. So if you will compare these two forces, you can find amount of height raised in this particular liquid in this tube, which is called Ascent formula. So in this part, I have just assumed consider a thin tube of radius r is dipped in liquid. Let level of liquid increases in tube to high H due to surface tension or adhesive force. So we have to calculate this H. Khalid, is it clear?
Yes, sir.
Now, let me define you what are the forces acting on this particular part. So this is tube, and this is the meniscus at its top point, and this is the total amount of liquid in this tube. So if you want to calculate its total volume, just draw a horizontal line at this point. So mainly we have two different parts. One is from this point to this point, and the other is from this point to this point. So how to calculate volume of this upper segment? Let me define you how to calculate. And this meniscus, it will be termed as hemisphere. So if you calculate, or if you want to calculate volume of this part only, radius of this tube is small r, and height of this particular term is also small r. So volume of hemisphere will be 2 by 3 times pi r cube. If you subtract it from this whole part, you will get amount of liquid that is at this point. So in total, its volume will be pi r square times h minus 2 by 3 pi r cube. That is volume of hemisphere, which is at this point. So on solving, you'll get pi r cube gets common. So 1 minus 2 by 3 will be just 1 by 3. So it will be pi r cube by 3. Any doubt till this part? Okay, first write it down to this. Just 1 minute. You all have done?
Done, sir.
Hamza, any doubt what I have calculated in this part?
No, sir.
Okay. So in this, you will say amount of force which is acting in downward direction due to gravity must be compensated by the amount of force due to surface tension. So if you calculate using surface tension component of force which is experiencing in upward direction, let me define you. At this interface, along this direction, surface tension acting will be T. If this was theta, so this must be theta. So it will have a component along this direction and another along this direction. So this will be termed as T cos theta, which is acting for about its perimeter from this point to this point, that is 2 pi r in upward direction to balance this liquid. So at equilibrium, total upward force due to surface tension must be equals to downward force due to gravity. Now, upward force due to surface tension will be equals to T cos theta times its length of interaction, that will be perimeter of that boundary, 2 pi r, must equals to total downward force, for which we have two different types. One is the cylindrical column. So force is mass times gravity. Mass will be density into volume times gravity. So density will be rho volume pi r square h times gravity for the cylindrical segment, plus density pi r cubed by 3 times gravity. So if you solve this particular expression, pi r will cancel out. So you're left with h equals to this 2t cos theta divided by rho g r minus r by 3. In general, this r by 3 is very small as compared to this left part, so we can neglect this particular portion. So instead of solving this above part, you will say this is small meniscus which is in upward direction shape of concave, we may neglect it. Hamza, is it clear?
Yes, sir.
But in actual, total height raised will be about this much. Khalid, any doubt?
No, sir.
Okay, just write it down.
So, sir, while calculating height, we don't have to like minus it with r by 3, right?
I have just calculated the above part as well as whole bottom part, but for your calculation, you may neglect this upper curve portion. So this r by
Oh,
3 we can neglect out. So you'll just consider this portion to be cylindrical segment having volume pi r square h times rho times gravity and equated to surface tension T2 cos theta 2 pi r.
okay, sir.
Or you may calculate as I have done. And last, you may neglect r by 3. You all are done?
Yes, sir, done.
Okay. Now, related to this expression, if r by 3 is neglected, so you're left with h is equals to 2t cos theta divided by rho g r, where small r is radius of that capillary tube, theta is angle of contact, and t is surface tension. So depending upon this theta, we may define if theta will acute, so cos theta will be positive, so h will be positive. If theta equals to 90 degree, cos 90 will be 0, so h will be 0. And if theta will obtuse, cos theta will be negative, so height will be negative. So this positive height means there will be upliftment or rise in level of liquid, so it will ascend. In third part, if theta is obtuse or height will be negative, so downfall of liquid, so it will be descent. And this middle part, there will be no change in level of liquid, so we'll say remain equilibrium at same level. So on the basis of theta, we may define its increase or decrease in level of liquid. Hiba, any doubt?
No, sir.
Now the next question will be how mass and radius will be related with one another. So next is radius and mass. Since h equals to 2t cos theta divided by rho g r, mass is equals to density into volume. So we may write density equals to mass divided by volume. And for the cylindrical part, volume will be pi r square h. If you put this in this expression, you will get 2t cos theta divided by m pi r square h divided by g into r is equals to h. So this h and this h will cancel out. This r and this r will cancel out. So if we move this mass to left side, m equals to 2t cos theta times pi divided by gravity or multiplied by r. So this mass is directly proportional to radius of that capillary tube. So smaller the radius of capillary tube, smaller mass it will withhold. Larger the radius of capillary tube, larger the mass will it hold. So m is directly proportional to radius of capillary tube. Khalid, is it clear?
Yes, sir.
So related to this part, you will be asked if a capillary tube having radius r carries a mass m, then the volume will be pi r square h.
Where is sir, by the way? You got disconnected?
I guess yes.
Yeah.
Okay, sorry for the inconvenience. It was not my fault. It was the fault of electricity. Okay. So do you have any doubt till this part? Khalid? Okay, first write it down. You will have written? Salman?
Yes, sir. Done.
Okay. In this part, there will be a question. A capillary tube of radius R having liquid of mass 5 gram. Find mass of liquid retained if radius becomes 2r. Just compare the above part and try to answer. Just see, we have initially radius r holding liquid of mass 5 gram. Now radius becomes 2r. So how will mass of liquid will change according to this relation? Hamza?
It will get doubled.
Good. So initially it was 5 gram. On increasing radius, mass will also increase. So new mass will become 10 gram. Salman, is it clear?
Yes, sir.
Okay. Next question related to this will be, a rise of liquid in capillary tube of insufficient length. Let me define you what do you mean by insufficient length. Suppose there is a tube, this, in which level of liquid may rise up to this point. Height h. Now, what will happen if you take a tube having height less than h or just h by 2? Suppose if you have inserted a tube of this much liquid or this much size, which is smaller as compared to h. Hamza, what will happen in this case? Will the level of liquid may rise up and get overflowed from this part or something else?
It won't overflow. Like,
Okay. It will overflow. Khalid,
Yes, sir.
will it overflow or will remain behind that ever part or tip?
Sir, I think it will overflow.
Okay. Let me define you according to the relation h equals to 2t cos theta divided by rho g r. This r on moving to left side, h into r equals to 2t divided by rho into g times cos theta. Since this entire term will always constant, so this r and theta will be proportional to what? Cos theta, which is nothing but angle of contact. And for a particular liquid and its interaction with that tube, cos theta will remain same. So this h into r, you will say it will always remains constant. So if h will decrease, r will tend to increase up to its maximum value or up to its last part. Is it clear?
yes, sir.
So in this part, if this tube is insufficient length or which is smaller as compared to h, so in this part, r tends to become maximum. What will be the maximum value of a particular dimension? You'll say infinite. Okay. So if length of tube is small as compared to amount of liquid raised, so in this part, R will tends to increase up to its maximum part. So R will tend to acquire its maximum shape, that is infinity. So if dimension of a particular object or length of a particular object becomes infinite, it will tend to become flat. So in this part, the level of liquid may rise up to this point, but after it, it may acquire flat surface, but still won't overflow. Is it clear?
Yes, sir.
So if tube is of insufficient length, meniscus of liquid or in this particular tube may get flattened at its topmost point, but will not overflow anymore. Hiba, is it clear?
Yes, sir.
Okay. You all have written? I think you have to write this part.
Done, sir.
Done, sir.
Salman, you have written?
Yes, sir. Done.
So this is all about this entire part, that is surface tension and its various application, or hydrostatics part. Next is hydrodynamics. Or study of liquid in motion. In this, we start with Newton's law of viscosity. According to Newton, liquid in a particular tube or in a particular chamber or in any object always flow in layer by layer structure like this. One of the layer having area this and its adjacent layer and so on, during which each layer opposes its neighboring layer by a force which is called viscous force. So this viscous force acting in between two layers of liquid must be along this direction, let's say Fv. Due to impact of this viscous force, there will be change in velocity of liquid. So this layer will be moving with some velocity v. So this layer must be moving with some velocity v plus dv. And there will be width between two different layers of liquid, let's say dy. Area of cross section of this liquid is, or layer of liquid is A. So according to Newton, liquid always flows in layer by layer structure in which each layer opposes its neighboring layer by a force which is called viscous force. This viscous force is directly proportional to area of liquid layer and also to the velocity gradient. Let me define you what do you mean by velocity gradient. In physics, we mainly define two different terms. First is rate. Rate is change in any quantity with respect to time. Rate of change of displacement, rate of change of velocity, and so on. Similarly, gradient is nothing but change in quantity with respect to length. Just say in this part, on going up with change in length, that is dy, velocity of layer is changing from v to v plus dy. Hamza, is it clear?
Yes, sir.
Now let me define you this Newton's law of viscosity. State liquid always flow in layer by layer structure. Each layer opposes its neighboring by a force called viscous, which is directly proportional to the area of liquid film and also to the velocity gradient. First, write it down till this part.
Understood.
Salman, you have written?
Yes, sir. I have written.
Okay. Now, according to this relation, viscous force is directly proportional to area of liquid and also to the velocity gradient. So we can write F viscous is proportional to area and F viscous is also proportional to velocity gradient. It means change in velocity divided by change in length. So on combining these two equations, you will get viscous force proportional to A times dV by dy, replacing this particular proportionality sign by any constant term. Viscous force equals to eta A dV by dy with some negative sign since viscous force is opposing in nature. This eta is nothing but coefficient of viscosity. Its SI unit will be Pascal second. Celsius unit, poise. So 1 Pascal second equals to 10 poise. This eta will depend upon temperature like this. Okay, just write it down. Hamza, done?
Yes, sir, done.
Let me give you a question related to this part. Suppose there is a table and a pulley attached with it, a block connected with a string, suppose there is liquid at its bottom, this part. If width of layer of liquid is 1 mm. And area is 4 mm square. You may write just 0.1 mm. Find mass of this block to move at constant velocity of 10 centimeter per second. If eta is 0.05 Pascal second. Let me define you how to simplify it. This layer of liquid, which is behind this block, must be experiencing some viscous force, or it will tend to oppose the motion of this particular block. So there will be viscous force along this direction. This force will be overcome by this mass, which must be experiencing a downward force due to gravity. So if these two forces will equal to each other, so this block will tend to move with constant speed, 10 centimeter per second along the right side. So in the above formula, F equals to eta A, change in velocity, times width. In place of F, put m times g and try to find the value of mass. Hamza, is it clear?
Yes, sir.
Okay, try to solve. Write each term in their SI unit. We have length 0.1 mm, area of cross section 4 mm square, speed, and coefficient of viscosity. Just put all these values in this part and simplify it. Take the value of gravity to be 10. Hamza, you got any answer?
Almost near, sir.
Okay. Khalid, you got any answer? Okay, Hamza, let me check. Mass equals to eta, which is 0.05. Area of cross section is 4 into 10 to the power minus 6. Velocity is 10 to the power minus 2. Divide by gravity 10, and width is 0.1 into 10 to the power minus 3. Replace this decimal. 100. This decimal 10. This part and this part will cancel out. This part and this part will cancel out. Okay. 4 into 5, 20. Divide by 10. 10 to the power minus 6. 10 to the power minus 2. Divide by 10 to the power minus 3. This 0 and this 0 will cancel out. So it will be 2 into 10 to the power 6 to 8 minus 3 minus 5 kg. Just 1 minute. Okay. Hamza, is it clear?
Yes, sir.
Khalid, any doubt?
No, sir.
Okay, just write it down. You all have written?
Yes, sir.
Okay. Now, on the basis of this viscosity, let me define you a relation. Since F equals to eta A dV by dy for this particular layer of liquid, since this force will act tangentially along this direction to this area of cross section. So if you rearrange this expression, eta will equals to F divided by A whole divided by dV by dy. dV by dy, dV is velocity, which may be written as dx divided by dt times dy. Dx is change in length, dy is its width. So we call this particular term as strain in terms of shear, or you can call it as shear strain, divided by time taken. So any quantity divided by time taken is termed as rate. So we can call this particular term as strain rate. This numerator part, F divided by A, so force acting to the surface tangentially per unit area, this will be termed as shear stress, or which is tangentially. So this ratio will become shear stress divided by strain rate. Hamza, is it clear?
Yes, sir.
Just write it down.
Done, sir.
Okay. Salman, done? Now, on the basis of viscosity, we may define types of flow of liquid in different tube. So next is types of flow of liquid. First is a tube in which if layer of each moves with same velocity v1 at this cross-sectional area, at this instant velocity of each layer is v2. This will be possible only if there will be no viscous force acting between the layer of liquid. So this type of flow is called streamline or ideal flow. For liquid to flow in this manner, there will be some limitation. First, liquid should be non-viscous. It should be incompressible, and it should be irrotational. Next is, if there is a tube in which liquid is flowing, so layer of liquid may get opposed due to its neighboring as well as due to its side wall. Similarly, in this part or along this direction. So centermost layer will move with maximum velocity and edge layer will move with minimum velocity or least velocity. This flow of liquid is called laminar flow. In this part, there will be viscous force as well as opposition due to wall of tube. In third part, suppose you have a tube in which there is a particle in the path of flow of liquid. Let's say there is a particle, or due to which this will move faster and may get curled at this open space. Similarly, this may get curled. This formation of circular formation is called eddies. So a flow of liquid in which there is formation of eddy is called turbulent flow. In this third part, suppose this middle layer is flowing with some velocity v and there is object in its path. So on collision with its path of this object, they may get stopped. So there will be a vacant space just after it. So the sideways liquid on flowing may get curled at that particular point to form ADs. So flow of liquid in which there is formation of ADs is called turbulent flow. So mainly we have these three different types of flow of liquid. Khalid, is it clear?
Yes, sir.
If there is formation of ADs, just write it down.
Well, sir.
Now, how to define these type of flow, streamline, laminar, or turbulent? To define it, let me define you a number on the basis of which we may distinguish different types of flow. Reynolds number. It defines the type of flow of liquid by assigning numerical value which depend upon some factor. Let me define you how to calculate. Suppose you have a tube in which liquid is flowing at some critical velocity, the velocity for which flow of liquid is streamlined. Diameter of tube is d, density of liquid is rho, and coefficient of viscosity is eta. Velocity of liquid is critical velocity Vc. So first, let liquid of density rho, coefficient of viscosity eta is flowing at critical velocity Vc in tube of diameter d. So let me define you what do you mean by critical velocity. So you say the velocity for which flow of liquid will be streamlined. The velocity of liquid for which flow is streamlined. Now, on the basis of above relation, we may calculate its relationship. Let's say critical velocity is depending upon density of liquid, coefficient of viscosity, diameter. So on the basis of its dependency, we may write critical velocity equals to some proportionality constant, rho to the power x, eta to the power y, diameter to the power z, according to the concept of dimensional analysis. Hamza, is it clear?
Yes, sir.
Now, write the dimension of each term on both sides. In left-hand side, we have velocity, which having dimension m0, L to the power 1, T to the power -1. K is any proportionality constant, so it should be dimensionless, so neglect it. Rho is density, which is mass by volume, raised to x. Eta, m minus 1, ml minus 1, t minus 1, raised to y, diameter, which is nothing but length, to the power z. So m having x from first part and from second part y, L to the power minus of 3x minus y plus z, and t to the power minus y. First, write it down till this part. You all have written?
Yes, sir.
Now just compare the exponent of each term on both sides and try to find the value of x, y, and z. On comparing the exponent, try to find the value of x, y, z. Hamza, you got any answer? We have m raised to 0 in left hand side and m raised to x plus y in right hand side. So on comparing the exponential, we can write x plus y equals to 0. Similarly, for the exponent of L, we can write minus of 3x minus y plus z equals to 1. And for third part, minus t equals to minus 1. So minus and minus will cancel out. So you'll get y equals to 1. Put it in first part. So x plus y is 0. So x will be minus of y. That will be minus 1. On putting these two terms in this middle equation, minus of 3x, which is minus 1, y, which is plus 1, z equals to 1. So minus minus plus 3 minus 1 plus z equals to 1. So z equals to 1 plus 1 minus 3. That will be minus 1. Hamza, is it clear?
Yes, sir.
Now, put these values in the expression and replace k by any constant number, that is Reynolds number. So Vc equals to Reynolds number, rho to the power x, which is minus 1, eta to the power y, which is plus 1, diameter to the power z, which is minus 1. We may write it as Re eta divided by rho times d. So on rearranging, you will get Reynolds number equals to rho Vd by eta. Now, using this formula, you may calculate for different term. First is, if numerical value of Reynolds number will be less than 1000, it will be termed as streamlined flow. Next, if Reynolds number is less than 2000, greater than 1000, so it will be laminar flow. And if Reynolds number less than 3000, greater than 2000, so it will be unstable. Between laminar and turbulent, and if Reynolds number is greater than 3000, then it will be turbulent. Iba, is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Hamza, done?
Yes, sir, done.
Okay. Let me give you a question related to this part. A tube having radius 10 centimeter, in which liquid having density 800 kg per meter cube and eta 0.05 Pascal second. Is flowing at 20 meter per second. Find Reynolds number and define its type of flow. Try to solve. You have radius, density, coefficient of viscosity, and speed. Put the above formula, try to find Reynolds number, and on the basis of which we may define its type of flow: streamlined, laminar, turbulent. Since we have to calculate Reynolds number, which is equals to rho v d divided by eta. Density is 800, velocity is 20, diameter is 0.2 divided by eta, which is 0.005. So 2 into 2, 4, 8 into 4, 32, divide by 5, so it will be 6.4 into 10 to the power 2 plus 1, 3 into 2, 10 to the power 5, which is large or very large. You will say it will be for turbulent flow. Good, Hamza. Khalid, is it clear? Salman, any doubt?
No, sir, no doubt.
Okay, you all are done? Salman, written?
Yes, sir, done.
Okay, let's stop here for today. In next class, I will define you the next part of this particular chapter, that is Stokes' law, terminal velocity, and Bernoulli's principle. Okay. Just revise this whole part and try to do problems. Okay. We'll continue next class. Okay, take care.
Yes, sir.
Allah Hafiz.
Thank you, sir. Allah Hafiz.
Allah Hafiz.